once again. Welcome to New Normal Science. We will continue our discussion with regards to atom. Now this time, it's main energy level and electronic configuration of elements or atom. So the main energy level is very important in order for us to determine the period number of an element or atom and its group number. With the main energy level, we can also determine how much electrons is present in each cell and what is the number of electrons in the outermost level or shell, which corresponds to the valence electron of the element or atom, which is very important in determining the chemical property of a given element or atom. First, let us discuss the different main energy levels. So the maximum number of shell or main energy of a given atom is 7. For example, this is the atom. So the maximum number of an atom can have is 7. So we have 1, 2, 3, 4, 5, 6, 7. So each shell or energy level consists of a specific number of electrons. So we have the first shell, second shell, third shell, fourth, fifth, sixth, and seventh. So we have 2 electrons. For the second shell, we have 8 electrons. Third shell, we have 18 electrons. The fourth shell, we have 32 electrons. The fifth, we have 32 electrons. Then we have 18, and we have 8. So that is the exact number of electrons for every level or shell in a given atom. And this one will vary. It depends on the number of proton or atomic number of an element. So let us give an example so that you know how to use the main energy level. Then we will identify the period number, the group number, and the valence electron of a given element using the main energy level. So let us start with the easiest one. For example, we have lithium. Lithium has atomic number of 3. So if we will follow the main energy level, the first shell of lithium is 2. So how many more electron left? So we have 1. Without looking at the periodic table, you can identify or distinguish or predict the period number of lithium and the group number of lithium. So the period number of lithium is 2 because there are 2 shells. So we all knew that the period corresponds to the number of shells and vice versa. And what about the group number? So the group number corresponds to the outermost electron of the element, and that is 1. So lithium belongs to group 1 or alkali metals. So that is 1. And the valence electron is also equal to 1 because group 1 is automatic to have a valence electron of 1. So let's have second example. So we have magnesium, atomic number 12. So for magnesium, we have 2 for the first shell. Then the second shell is 8. So we have 2 plus 8, we have 10. So 12 minus 10, we have 2. So what is left is 2. Okay? So we have 2, 8, 2. So the total is 2 plus 8 plus 2, we have 12. So if we are going to determine the period number of magnesium, so that is 3. Magnesium belongs to period 3. And group 2. So the valence electron is also equal to 2. So main energy is very useful. What about the elements at the right side of the periodic table? So this main energy level thing is very useful only for representative elements, okay, or the group A elements. So let us have aluminum. So aluminum is 13. So we have 2, 8, and 3. Okay? So same with magnesium, it has 3 shells. So it belongs to period 3. And the last shell has 3 electrons. It belongs to group 3. And the valence electron is equal to 3. Okay? So what about the other element? So we have the fourth one. So let's say we have chlorine. So we'll increase the atomic number. So for chlorine, we have 2, 8. So how much more is the remaining? So we have 17 minus 10, we have 7. So 7 is the last electron. So we have how many shells? 1, 2, 3. So chlorine belongs to period 3. And what is the number of electron in the last shell or outermost shell? And that is 7. So therefore, chlorine belongs to group 7. And the valence electron is 7. So let's have bromine. Bromine is 35. So we have 2, we have 8. So we have 2 plus 8, we have 10. So we still have 25. So we can still write 18. Okay? So we need to subtract that one. So what is left is 7. So we can write 7. So how many shells are there in bromine? So we have 1, 2, 3, 4. So bromine belongs to period 4. And what is the last shell? Electron. So we have 7. So therefore, it belongs to group 7. And the valence electron is also 7. Okay? So main energy is very useful in determining the number of electron in the outermost shell and the period number of a given element. Let us have the case of calcium as example number 6. So calcium is 20. So we have 2, 8. So that is 10. So we still have 10 more. Can we write 10? No, we cannot write 10. Why? Because it should be divisible by 2, 8, 18, and 32. So we cannot write 10. So therefore, the closest one is 8. So if we write 8 there, what is left is 2 electrons. So we write 2. Okay? So let us confirm whether our answer is correct. So we have first shell 2, 8, 8, 2. And there are 4 shells. Calcium belongs to period 4, and that is correct. What about the group number? Calcium belongs to group 2. So the last electron is 2. That is correct. So the valence electron is 2. Okay? Now, there's a shortcut for this one. Okay? But before I will teach the shortcut for the electronic configuration, I will teach you first what is an electronic configuration all about. So electronic configuration, it describes the number of shell, the number of electrons per every shell, the orbital, and the subshell. So we all knew that we have the different shells. We also have the different subshells. So we have the different subshells like the S, the P, the D, and the F. Each of this corresponds to the maximum number of elements they can hold. S can hold only 2 electrons, while P can hold 6 electrons, and D can hold 10 electrons, and F can hold 14 electrons. So that is the maximum number of electrons for every subshells. Okay? So let us write the mnemonic device or electronic configuration device. So we have the first shell, 1s2. The second shell, we have 2s2, 2p6. The third shell, we have 3s2, 3p6, and 3d10. Then we have 4s2, 4p6, 4d10, and 4f14. Then we have 5s2, 5p6, 5d10, 5f14. Then we have 6s2, 6p6, 6d10. Then we have 7s2 and 7p6. Alright? So if you still remember our lecture a while ago, so we have 2, 8, 18, 32, 32, 18, and 8 for this particular number of shell. So we have 7 shells, 1, 2, 7. Okay? So now, what is the flow of this electronic configuration? Can we just write this one according to this flow? So we need to follow the flow of electrons for every subshell. Okay? So we have 1s2 going to 2s2. If that one is filled and you need to write more, you go to the 2p6. Then after that, 3s2. Then after 3s2, 3p6. Then 4s2 before you go to the 3d10. Then after 3d10, you can write 4p6, then 5s2. After 5s2, it's 4d10. Then after that, we have 5p6, 6s2, then 4f14, then 5d10, 6p6, 7s2, then move to 5f14, 6d10, and the last one is 7p6. So you need to go to that kind of order. Okay? Now, so I taught you how to do the main energy a while ago. So we can also use that knowledge in doing the electronic configuration of a given element. Okay? So let's have an example. So we will use the example a while ago. So we have lithium, so that is 3. So we have 2 and 1 for the main energy. Now, for the electronic configuration, okay, so we have 1s2, okay, then the next one is 2s1. So why 1s2? So the first shell has 2 electrons, so that is the first shell, and that is the subshell holding the electron, which is 2, so that is correct. Then the second one is only 1, so that is second shell, and for the S subshell, it can hold a minimum of 1 and a maximum of 2. So we can write 2s1 only. Okay? Then, second example, we have magnesium, and that is 12. So we have 2, 8, 2. So let us have its electronic configuration. So we have 1s2, 2s2, 2p6. So we have 2, we have 8. So next is 3s2. Okay? So the first shell is 2. Second shell is 2 plus 6. So that is 8. The third shell is 2. Okay? So that is correct. Now, so let's have the third one. We have chlorine, 17. So we have 2, 8, 7. So we have 1s2, 2s2, 2p5. The next 3s2. Then the last one is 3p5. Okay? So the subshell P can hold maximum of 6. Okay? So we only need 7 for the third shell. So that is 2 plus 5 equals 7. Okay? So that is for chlorine. Okay? Hope you can still follow. So we have number 4. We have bromine. So bromine is 35. So we have 2, 8, 18, and 7. So the electronic configuration of bromine is 1s2, 2s2, 2p6. Then we have 3s2, 3p6, and 3d10. Then the last one is 4s2 and 4p5. Okay, so that is the electronic configuration using the mnemonic device. Okay, so I will teach you the shortcut, the one that you see in your periodic table. Okay, there is an annotation at the bottom of each element or atom, okay, using the core electron. Okay, so we will use the core electron. So what is core electron? Okay, So electron is by using the noble gas. Okay. So at the far right side of the periodic table, or the inert gases. So what are these? So we have neon, argon, krypton, xenon, and we have radon. Okay? So neon has atomic number of 10, argon is 18, 36 for krypton, 54 for xenon, and 86 for radon. Okay? Now, we will put a bracket for every noble gases that we use, okay, in our shortcut electronic configuration or electronic configuration using the core electron. So, but first, let us identify the ranges of its atomic number. Okay? So, neon can only be used for atomic number 11 to 18. Okay? Then argon, we have 19 to 36. Then for krypton, we can only use that one for atomic number 37 to 54. Then the next one for xenon, we have 55 to 86. Then we have radon, 87 to 118. So this is easy to remember. If neon is 10, it will start at 11. Then it will terminate at 18 for the next noble gas. The same with argon. Argon is 18, it will start at 19 and end with the next noble gas, and that is 36. Then 36 for krypton, start at 37, terminates at 54. Xenon is 54, it will start at 55 and ends or terminates at 86. Then radon is 87, and the last one is 118. Okay? So let us have an example. Okay? How to use this core electron. So for example, we have sodium. Okay? So sodium is 11. That is the atomic number of sodium. So we can use what core electron or noble gas? Very good. We can use neon. Okay? So neon is 10. It will start at 11. So sodium is 11. Okay? So how many more left? We have 1. Very good. Okay? So we can write 3s1. Okay? How did I know that the last one is 3s1? Okay? Because I know that is 10. That is already 1s2, 2s2, and 2p6. Okay? That is equivalent to 10. So what is left is the third shell, which is 3s1, because I know sodium is third shell and the group number is 1. Okay? You can still follow? So let's have magnesium. Magnesium is 12. We can still use neon. So neon, then you just increase it by 1. So it's 3s2. Okay? So 10 plus 2, we have 12. And let's have calcium. So we have 20. So we can use, very good, argon. Because this is the atomic number range, no? We have 20. So for calcium, we have what? So how many more left? So that is 18 for argon. So we need 2 more. So that 2 more is 4s2. Because calcium is belong to period number 4 and group 2. Okay, so that is the last one filled, no? Next, we have bromine. Let's have a complicated one. So 35. So we will use argon. So argon, so that is 18. So we need more, 17. Okay, so we need 17. Can we just write 17? No. So what is 17 there? Okay, for bromine. So the first 18 is here. So we have 2 plus 8, so that is 10. Okay, then that one is how much? 8. So 18. Okay, so that is for argon core. Now what is left is 17. So we can write 4s2. Okay, 4s2. You can still see that one? I don't think so. So I will adjust it. Okay, so we have, I will write it at the bottom. So we have 4s2, 3d10, and 4p5. Okay, so we can also rearrange that one so that you will fully understand that the last shell is 7. Okay, so I will just rewrite it. So we have 3d10, 4s2, and 4p5. Okay, so we have 18 for argon, and this is 17, and that is the flow of electrons in the electronic configuration. So we know that bromine belongs to period 4. That is why the last shell has 4 in it. Then we know that bromine belongs to group 7. So the last electron has a sum of 7. So we have S2 for that one, and P5. So that is 2 plus 5, and that is 7. Okay? So that is for the electronic configuration using the core electron. Hope you understand our lesson for today. So thank you so much.